Which year your second sem or fourth sem?
Sorry?
This is fourth sem class only, no?
Yes, ma'am. Fourth sem.
Okay. Now you have optics syllabus, interference and diffraction, huh?
Yes, ma'am.
Okay. So once you have textbook, once show me, ma.
Actually, don't have it, ma'am.
Syllabus I want to start. They're saying sometimes sixth, sometimes fourth, sometimes second. That's what I am. Maybe it is fourth sem means which syllabus you have that I want to start now. Quantum theory of radiation, thermodynamics, thermal properties, that all over now. Statistical mechanics. Just video on and share, don't share, not allowing, I think. Just video on, show the answers, that syllabus, what it is. Mamata. I don't have syllabus, ma, Pro 5G. Okay, we'll start the syllabus. So that is optics means interference, diffraction, polarization, that related topics is there, ma. Now I want to start interference, diffraction, polarization lesson. Interference means depending upon the principle of superposition, we are getting the interference concept, ma. So interference, diffraction, polarization, and optics, you have what it is, optical fibers you have in that portion. So first of all, what is interference? What is diffraction? Interference is the phenomena in which interference is the phenomena of interaction among two distinct waves, propagating wave two coherent sources, propagating the waves between two coherent sources, ma. That is interference phenomena. Now diffraction means it is the bending of light from the obstacle. Here diffraction is the separate topic and interference is the separate topic. My interference, we have the two types based on wavefront, based on wavelength. Is it audible? Yes. Is it visible on the screen? So interference and concept of interference, principle of superposition, coherence sources definition is there, ma. Light is a form of energy. Light is a form of energy which is transferred from the source of light of the eye. Is it visible, ma? Yes. Is it visible, Anna?
Yes, ma'am.
Okay. So first one, what is interference phenomena means introduction we are giving to that, ma. According to Newton's corpuscular theory of light, a source of light continuously emits a tiny in size light.
Ma'am, which unit are explaining?
What now?
Which unit are you explaining? Here, first unit is covered as Engine's principle and Young's model's experiment of light.
Which one is there? First unit?
First unit, Hume's principle and Young model experiment of light.
Tell me once again, ma, not audible.
Here, block 1 has 2 units.
First unit?
First unit, Hume's principle and Young's experiment of light.
Newton's laws, Newton rings, no?
Hume's principle.
Interference only, no?
Hume's principle
Yes,
Hume's
Newton
principle,
rings, Young's double slit
laws of
experiment is there. Fringe
laws
wave.
of reflection, laws of reflection.
What, ma? Tell. No. Young's principle mean that is related to interference only, no? Interference fringe width you want to find out. Young's principle, Brenner, trapezium, Lloyd's experiment that you have.
Okay, ma'am.
Okay. It is a concept of interference only, ma. So once you share that syllabus, ma.
I'm trying, ma'am, but it's saying not supportable.
Okay. On your video and show it.
We can't share both the screens, ma'am. If you stop the screen sharing, I can show.
Don't share screen, ma. Just show turn on your video and show me.
I don't have the material, ma'am. I just have PDF.
Okay. So what lessons you have in that first third syllabus one? So you tell me. First unit, what is the lesson?
First unit, ma'am. Hume's principle and Young's modulus of light. First unit.
Okay. Second.
Second unit, application of interference.
Okay. Third.
That concludes block 1, ma'am. Next, block 2.
This is fourth sem syllabus only.
Fourth sem syllabus. First block has 2 units. I already told the 2 units for you.
Young's modulus, experiment, and applications of interference.
Application interference, Hume's principle.
Okay. Next, third, fourth.
Third for Fresnel's and Fresnel's diffraction. Fresnel's diffraction at the edge light, straight edge.
Okay.
Fifth unit, plane diffraction, granting measurement of wavelength of light.
Okay.
Unit 6, resolving power and dispersion of granting.
Okay.
Block 3, polarization. Unit 7, plane polarization,
polarization. Okay.
Of reflection. 8th unit, production and analysis of different types of polarized light.
Okay, okay, okay. So
Unit
after
9, Unit 9, rotatory polarization.
okay, okay. And you have total interference, diffraction, polarization concept in this fourth sem syllabus, sir.
Uh,
Okay then.
and the block 4 has the lasers and holographs, those controls.
Okay, Padma holography.
Lasers and holography.
Okay, okay. That also you have. That is fourth block, huh?
Okay. Yes, ma'am.
Okay, okay. Total interference, diffraction, polarization, holography is there.
Yes, ma'am.
Stages. Okay. Okay. So we'll
Okay.
start
Okay.
interference. That only first part is interference, and Young's principle also covered in that. Application of interference is nothing but Young's principle, ma. Okay, now we'll start the
Okay. Okay.
interference. So what is coherence? What is coherent sources? What is principle of superposition? So that we'll start first interference phenomenon. Interference we are giving, it is working on the principle of superposition. You observe that principle of superposition. It is visible on the screen now.
Yes.
Principle of superposition. Is it visible, Nana?
Yes.
Yes, ma'am.
Okay then. Understand that what is interference? But two waves of superimpose one over the other. Alternatively, one place intensity is maximum, one place intensity is minimum. Where the intensity maximum is constructive interference, where the intensity is minimum is destructive interference. So that alternatively, bright and dark bands are formed based on the principle of superposition. So that two coherence and coherent sources, principle of superposition, if you know, then you can understand the concept of interference. Then temporal coherence, spatial coherence, and conditions for interference of light. Before going to that, first we'll go for principle of superposition. In that, what it is, the resultant displacement of a particle of the medium acted upon by two or more waves simultaneously is the algebraic sum of the displacements of the same particle due to individual waves. In the absence of others, it is also known as superposition principles. So that here y1, y2 are the individual displacements of the two waves. Generally, displacement of the wave equation is considering as y1 and then y2. So that two resultant wave is nothing but y is equal to y1 plus y2. So that when phi is equal to 0, 2 pi, 4 pi means phi is equal to 2n pi. 2n pi if you are considering. Then what is the resultant displacement? Y is equal to y1 plus y2. If phi is equal to 2n plus 1 into phi, then what is the phi displacement value? Negative means subtraction we are taking. Y is equal to y1 minus y2, where phi is the phase difference between the two waves. Where phi is the phase difference between the two waves. It is clear? When the phase difference is 2n pi, then it is constructive interference. Y is equal to y1 plus y2. Where phase difference is 2n plus 1 into 5, then y is equal to y1 minus y2. Where phi is the phase difference between the two waves. Next one, coherence. What is coherence? Two wave sources are perfectly coherent. Two wave sources are perfectly coherent if they have a constant phase difference. If they have a constant phase difference and the same frequency and the same waveform, the phenomenon is known as coherence. Two waves of sources are perfectly coherent. When it is possible, if they have a constant phase difference and the same frequency and the same waveform. The phenomenon is known as coherence. Next one, coherent sources. So whenever the interference occurs, definitely the two sources act as a coherent sources. When it is said to be coherence means they have constant phase difference, same frequency and the same waveform. Okay, next one, coherent sources. The two wave sources which are maintain zero or any constant phase relation between themselves are known as coherent sources. This phenomenon is called coherent sources. This phenomenon is called as coherent sources. The two wave sources which are maintain zero or any constant phase relation between themselves are known as coherent sources. One another constant phase difference maintained, then it is said to be two coherent sources. This phenomenon is called coherence. Coherence is the ideal property of waves. That means enables stationary interference. Coherence is the ideal property of interference. It is the stationary interference. Here two types of interference is there. One is temporal coherence, one is spatial coherence. Next, what is temporal coherence means? Temporal coherence is the measure of the average correlation between the values of wave and itself delayed by coherence time. Therefore, T is any particular period of times. It characterizes how a wave can interfere with itself at different time. Therefore, it describes the correlation between waves observed at different moments in time. Here, two positions P1, P2, we are taken from the S is the source of light. P1 and P2 are the 2 points on the same wave at different moments of time. So 2 points on the same wave at different moments of time. S is the source. Now consider a monochromatic source of light as at any 2 points P1 and P2 on the same waves as shown in first figure. Consider the situation in which the path is average wave is extended. Now, hence the phase difference between P1 and P2 will depend on the distance between the points. Okay. So that here the distance between P1 and P2 is the coherence length. If the distance between P1 and P2 is less than coherence length, if the distance between P1 and P2 is less than the coherence length, then the wave maintains constant phase difference between P1 and P2 and takes place interference pattern. Therefore, if the distance between P1 and P2 is greater than, if the distance between P1 and P2 is greater than coherence length, there is no phase relation. As a result, there is no phase relation. As a result, we can calculate the distance value. Okay. Now, correlation of the wavelength can be considered as interference phenomena. Now, if the distance between P1 and P2 is less than if the distance between the points is less than the coherence length, then what we are taking on the screen, ma'am? P1 and P2.
Excuse me, ma'am.
Yes.
Is it 4th sem classes, ma'am?
Yes.
Okay, ma'am. We got just now message so that we joined now.
Okay. Yes, this is 4th sem.
Okay, ma'am.
3rd sem completed exams, sir?
Yes, ma'am. Completed.
You completed last March to 22nd March.
Yes, ma'am.
Okay. How you wrote, ma'am?
Well, ma'am.
Very nice, huh?
Somewhat.
Thermal physics you completed there. Thermal physics you completed, no?
Yes, ma'am.
Okay. Now it is optics. Optics means interference, polarization, diffraction, lasers, holography. These topics are main importance in this 4th sem. Okay. Now temporal coherence means if the distance between P1 and P2 is less than the coherence length, if the distance between P1 and P2 is less than coherence length, then the wave maintains constant phase difference. When the wave maintains constant phase difference, P1 and P2 and takes place interference pattern. If the distance between P1 and P2 is greater than coherence length, if the distance between P1 and P2 is greater than coherence length, then there is no phase relation. As a result, interference loses sharpness or contrast. That is called temporal coherence. Next one, spatial coherence. What is spatial coherence? If the phase difference are for any two fixed points in a plane normal to the wave portion does not vary with the time, then the wave is said to be exhibit spatial coherence. Okay.
Ma'am, excuse me, ma'am.
Tell me, ma'am.
Ma'am, in temporal coherence, is there any angle is formed, ma'am?
In angle.
Yeah, ma'am, angle, ma'am.
Angle not there, no? That is straight line, parallel line. Parallel line, there is no angle, no?
Yeah, okay, ma'am.
Spatial coherence, you have the angle.
Yeah, ma'am, okay, ma'am.
Perpendicular that, then it is angle. If
Yeah,
the phase difference for any two fixed points in a plane normal to the wave propagation does not vary with the time, then the wave is said to exhibit spatial coherence. Spatial coherence describes the correlation between waves at different points in space. It gives the relation between waves at different points, means it makes certain angle. In general, it is the condition for path difference between waves to produce interference pattern. Here means according to that what it is the 2D path difference we are taken what it is in fourth paper. Path difference between two waves is given by 2D sin theta. 2D sin theta. Wait, I will send you. Okay, now here S1 and S2. S1 and S2 be the two sources. S1 and S2 be the two sources and P be a point of observation as shown in figure already. So before figure we are giving that S1 and S2 be the two sources, and for that comparison sources are S1 dash and S2 dash. These two are acting at the point P only. Therefore, path difference between the waves is given by S2P minus S1P is equal to 2D sin theta. S2P minus S1P is equal to 2D sin theta. Therefore, in general, that emission of time is 10 power minus 6. Hence, the corresponding length is C into 10 power minus 9, where C is velocity of light. Velocity of light. Therefore, to produce interference pattern, the path difference should be less than C into 10 power minus 9. Generally, path difference is 2D into sin theta. Here, path difference less than C into 10 power minus 9. Then interference phenomena will be produced. Therefore, S2P minus S1P is equal to 2D sin theta less than or equal to C into 10 power minus 9. In our consideration, it is valid for S1 and S2 only. In our consideration, it is valid for only S1 and S2 only. Therefore, then the path difference becomes S2 dash P minus S1P. And the spatial coherence becomes poorer. If the path difference between two waves is greater than C into 10 power minus 9, then the interference fringes loss sharpness or contrast. The interference phenomena is less than C into 10 power minus 9 only, it will be observed clearly. If it is more than C into 10 power minus 9 means the interference fringes are sharpness or contrast. Now, if you want to produce interference, some conditions are required. Now, what are the conditions required to produce interference phenomena? Means first point, the two interfering beams must originate from the same source of light. Okay, first point, what you are taking, the two interfering beams must originate. The two interfering beams must originate from same source of light. This is ensemble for producing stationary maxima and minima. Since the stationary maxima and minima, the phase difference should not vary with time. Phase difference should not vary with time. That is the initial phase difference. Therefore, the initial phase difference between the interfering waves must be 0 or constant. Initial phase difference must be 0 or constant. Then the sources producing this type of waves are said to be coherent sources. phase difference are initially having the zero or constant, then this type of waves are said to be coherent sources. Next one, the waves must have the same period. The waves must have the same period and wavelength, also their amplitudes, and wavelength also their amplitudes must be equal or very nearly equal. Okay, now the original source must emit, light of single wavelength. Take the screenshot, this is important for 4 marks. Conditions for interference. What is interference? What are the conditions for interference? What are the types of coherence and coherent sources? Principle of superposition. Define principle of superposition and from that derive the interference and the conditions for interference. 5 marks question mark. Next one, the two interfering waves must propagate almost in the same direction. The two interfering waves must propagate almost in the same direction. That is, the two interfering waves fronts must intersect at a very small angle. The two interfering wavefronts must intersect at a very small angle. Therefore, interference. Next, this is the actual definition. Our portion starts from here. Interference. The phenomena of modification of redistribution of intensity of light. The phenomena of modification of redistribution of intensity of light in the region of superposition is called interference. Interference takes place on the basic principle of superposition. Okay. There are types of interference. The phenomenon of interference is divided into 2 types. One is the division of wavefront, one is division of amplitude. Division of wavefront, these are nothing but applications of interference. Second lesson. Okay. All this becomes under the applications of interference. There are 2 types of interference based on wavefront, based on amplitude. First one, division of wavefront. So based on division of wavefront, we have to take 2 one. One is Fresnel's biprism, one is Lloyd's mirror. The phenomenon of interference is divided of 2 types, wavefront and amplitude. Division of wavefront. What is division of wavefront? The incident wavefront is divided into 2 parts. The incident wavefront is divided into 2 parts by utilizing the phenomenon of reflection, refraction, and diffraction. These 2 parts of the same wavefront, travel unequal distances and reunite at same angle to produce interference bands. Example, Fresnel's biprism, Lloyd's mirror, etc. And then second one is division of amplitude. There we can take Newton rings and Michelson interferometer. Okay, division of wavefront to division of amplitude. Division of wavefront is Lloyd's mirror, Fresnel's biprism. Division of amplitude is Newton rings, Michelson interferometer. All these 4 are important only. Next, division of amplitude means the amplitude of incoming beam. The amplitude of incoming beam is divided into 2 parts. The amplitude of incoming beam is divided into 2 parts, either by parallel reflection or refraction. These divided parts reunite after traversing different paths and produce interference. Example, Newton rings and interferometer, etc. Now we'll start for Fresnel's biprism. This is also important question in these are nothing but applications of interference. Now here figure and how to determine the wavelength of light using this Fresnel's biprism. Okay, ma'am. Measurement of fringe width, measurement of wavelength of light, measurement of distance between 2 slits. So for that, first you observe the diagram. In this diagram, we have what it is. A biprism is essentially a combination of 2 acute prisms. 2 acute prisms to take the combination. Here the slits are S1, S2. The difference between the 2 slits is 2D. Are you observing? On the screen, we can take the eyepiece. So 2 sources and center one is the main source acute prisms here combined, that is called as Fresnel's prism. The working figure of that Fresnel's biprism is shown in down. Okay. A biprism is essentially, once I will explain clearly, ma, you can take the screenshot. You have any doubt, ask in next class. Okay. A biprism is essentially a combination of two acute prisms placed base to base, two acute prisms placed base to base. But in fact, this combination is obtained from an optically plain glass plate by proper grinding and polishing. The accused angle of the prism is about 179 degrees. One angle is 179 degrees and remaining is total angles is 180 degrees only. One is 179 means remaining others are 0.5 and 0.5 only. Therefore, the action of the biprism is to produce two coherent images. The action of the biprism is to produce two coherent images of given slit. So a biprism is essentially a combination of two acute prisms placed face to face. But in fact, this combination is obtained from an optically plain glass plate by proper grinding and polishing. The accused angle of the prism is about 179 degrees and the other angles are about 0.5 each one, nothing but 30 minutes each. The action of the biprism is to produce two coherent images. The action of biprism is to produce two coherent images of a given slit, which are separated at a certain distance and behave as two coherent sources. The experimental arrangement of biprism as shown in figure. It consists of an optical bench carrying four stands. The first one for an adjustable plate, second one for biprism, third one for convex lens, fourth one for micrometer. Okay. Experience. The stands can be moved along as well as right angles to the length of the optical bench. The slit and biprism can be rotated in their own planes. A narrow slit S is illuminated. So in the down, you're observing that 4 is standard on a same optical bench of eyepiece. Here a narrow slit S is illuminated with a monochromatic light as shown in figure. A source of light of wavelength lambda and is allowed to small symmetrically on a biprism. The intersection of the two inclined faces forming accused angle must be adjusted accurately parallel to the slit. Okay. The edge be divided into two parts. One is above half ABE and another one is below half BEC. Okay, the experimental arrangement of biprism as shown in figure. It consists of an optical bench carrying four stands. The first one for an adjustable slit, second one is for biprism, third one for convex lens, and fourth one for micrometer eyepiece screen. The stands can be moved. Along as well as right angle to the length of optical bench. The slit and biprism can be rotated in their own planes. Now a narrow slit S is, you following ma? Second figure I am explaining here. First figure experimental arrangement ma. So distance, what is the 2D, what is the T, what is the eyepiece, what is the distance between that wall observing from the first figure. Now we will go for second figure. Now a narrow slit S is illuminated with a monochromatic source of light wavelength lambda and is allowed to fall symmetrically on a biprism. The intersection of the two inclined faces forming accused angle must be adjusted accurately parallel to the slit. We can take the accurate values The edge B divides the incident wavefront into the edge B divided into incident wavefront of two parts. Firstly, the one which is passing through the upper half is ABE, and second deviated through a small angle the lower half diagram and appears to diverge from S1. Secondly, the one which passing through the lower half is PBE. Is it observed, ma? So here acute as angle we can taken as ABC and BEC. Is it clear? Now that is deviation. Secondly, half is CBE. Now deviated through a small angle. Okay. Now deviated through a small angle, towards the upper half and appears to diverge from S2, and hence S1, S2 serves as a coherent sources. S1, S2 serves as a coherent sources. As a result, two emergent waves intersect and give interference pattern. As a result, two coherent sources S1 and S2 serves as coherent sources. Two emergent wave fronts intersect and gives interference pattern, and it can be seen by IP. Okay, ma'am. Here, what is the wavelength of the light means? We can calculate using this Fresnel's biprism, ma'am. If determination of wavelength of light, that is under the side heading in Fresnel's biprism. If lambda be the wavelength of light used, if lambda be the wavelength of light used, beta be the fringe width, and 2D be the distance between two virtual sources, S1 and S2, and D be the distance between the slit and eyepiece. Then the wavelength of light is given by beta is equal to lambda D by small 2D ma. If and lambda is equal to beta 2D by capital D, which is equation are considered as 1. In order to calculate the wavelength of light, we can following the measurements are made. One is measurement of fringe width beta. The vertical crosswise is adjusted on any bright fringe, and the reading of micrometer screw is noted. Now we set the crosswire one by one on different bright fringes and note down the micrometer screw reading in each case. That means distance between the two bright fringes beta is calculated. Next one is measurement of D. The distance between slit and eyepiece. Can be read directly on the optical bench. Directly using scale, we can find out the slit and eyepiece. Now measurement of 2D. For that, what we are considering a lens with focal length less than 1/4 of the distance between biprism and eyepiece is mounted between biprism and eyepiece as shown in figure. The lens is adjusted at a position L1 till sharp images of S1 and S2 are obtained in eyepiece. In this case, the distance between the slit and lens is objective distance. In this case, the distance between the slit and lens is objective distance U, while the distance between the lens and eyepiece is image distance V. Now the magnification is given by M1 is equal to D by U, D1 by 2D. Further, at the position L2 of the lens, the sharp images of everything calculated part I was sent at the screen. Once you observe clearly, is there any doubt? Ask in your next class. Everything I want to send to you. Okay, derivation part clearly stepwise I will send you each and every topic. while explaining the topic. Okay. Now, here first equation in this under the heading, first equation is what is magnification of my image distance by object distance. Image distance is V, object distance is U. So nothing but D1 by initial distance is 2D, that is equation 1. Similarly, for second lens, M2 is equal to U by V, that is D2 by 2D, which is equation number 2. Now multiplying equations 1 and 2, then what you are getting, M1 into M2 means V by U into U by V. U cancel. Then D1 by 2D into D2 by 2D. Then U cancel, VV cancel means D1 D2 by 2D whole square is equal to 1. Then 2D square is equal to D1 D2. 2D is equal to under root of D1 D2, which is equation number 3. Now what it is, thus wavelength lambda can be determined by measuring the values of everything, beta, D and 2D. Beta value, 2D value and D values, then from equation 1, first starting determination of wavelength of light. You have the wavelength equation, no? Lambda is equal to beta, 2D and D. If you know all these values, you can substitute in that formula. Then you are getting the wavelength of light using Fresnel's biprism. Okay. Is it clear enough? Now you have another class, 1 o'clock?
At 1:30, ma'am.
1:30, okay. Is there any Fresnel's biprism clear, ma?
Yes, ma'am. Ma'am, one should show the topics, ma'am.
What, ma?
Topics.
Which topic? Lesson name, sir?
Yes, ma'am.
Excuse me, ma'am.
Tell me, ma.
Practicals of third sem, ma'am. When are the practicals?
They will give intimation for you, ma. This you have completed in second sem, ma. Kinetic theory of gases. Yes?
Ma'am?
This what I sent and now is it visible on the screen?
Ma'am, it is third sem, no, ma'am?
Yeah. This you have completed in third sem.
Yes, ma'am.
Okay. Fourth sem means optics. I will send you it. I think this month ending only, ma. Fifth sem paper is there. Then your classes, practicals, they will give intimate to you. Your numbers is there, no? And you can search in online. Okay, ma'am. Now it is optics. Page. Syllabus dragged here, right, ma'am? I will send this tomorrow, ma. That PDF not there here. I will send you your syllabus. Okay. Tomorrow I will share you. Okay, Nama. Tomorrow I will share you syllabus.
Okay, ma'am.
Okay. We'll continue next class, ma.